In 14.3, there are not very many problems, but the one thing I want to point out to you is that there is a typo. If you look at your check sheet, your check sheet says solving rational expressions. It should say solving rational equations because they're equations, not expressions. I realized it after I was typing up your notes. I go, oh man, I made a typo on the check sheet. They're not expressions, they're equations. And because these are equations, it's easier just to clear the equations of fractions by multiplying each term by the LCD. Or as you might also know it, the LCM. I'm going to put that in there, since I hear most of you call it that, or you know it as that. This only works, clearing fractions only works when there is an equation, when there's an equal sign, when you know what it is equal to. Then you're going to solve the problem. You may need to use the zero product property or even the quadratic formula. And make sure your answers are included in the domain. So keep in mind that if you're working out a problem that, let's say, looks like number 4. If you're working out a problem like number 4 and you get an answer or 2 answers, make sure that one of your answers is not 3 or -4. If one of your answers is -4 or 3, can you use it? Even though mathematically you found it, the answer is no. If it's not a part of the domain, you can't use it as a solution. Keep that in mind. I say that because I remember when I taught Algebra 2 that we would throw in some problems that had some questions that were not a part of the domain be part of the answer that you would work out mathematically. You have to know that that's why we taught you Section 1 first. Section 1 was designed to teach you, don't forget to check the domain. Here it doesn't say assume no variable or no denominators equal 0. So I have 2 examples for you on this. I have example number 2 and example number 4 will you do. If you want to do this on a separate sheet of paper, you are welcome to do so. It says x squared divided by 2 minus x equals 3/4. We need to solve for x. We need to figure out what x could be. So when I look at this problem, I'm going to multiply each term by the LCD or the LCM. So I'm going to look at all the little denominators again. Little denominator, little denominator, little denominator. And I'm going to look for what can they all go into. The smallest number and or variables that they can all go into. And they all can go into 4. And what I'm technically going to be doing is taking this whole thing and multiplying by 4. 4 is going to go here. 4 is going to go there. 4 is going to go there. When you do that, all the little denominators should go away. 2 goes into 4 2 times. 2 times x squared is 2x squared. Minus 4x over 1. You don't need to write over 1. Equals 4 goes into 4 one time. 1 times 3 is 3. And so what I now have is the same equation except it doesn't have any fractions. So clearing an equation of fractions is kind of nice to do sometimes. And you can only do that when there's an equal sign. I can't tell you how many times people have tried to clear fractions when there's no equal sign. And you can't when there's no equal sign. So now, when I'm solving an x squared problem, the only way to solve this is to use the zero product property. 2x minus 4x minus 3 equals 0. And what I would try to do if I were you is I would try to factor it first. 2x times x is 2x squared. And then 3 and a 1. Let me see. 3 and a 1. 2x times 3 is 6x, and a 1x does not make 4x. That does not work. Oh, that's 6x. And 1x does not make 4x. So let's try 1 here and 3 there. 2x. And 3x does not make 4x. If it doesn't factor nice and evenly, what does that mean that we have to do? Quadratic formula. So if you forgot what the quadratic formula is, negative b plus or minus radical b squared minus 4ac over 2a. Hey. So then I look at which one's which. Opposite of b. Opposite of negative 4 is positive 4. Plus or minus radical b squared. Negative 4 times negative 4 is a positive 16. Minus 4 times a times c. All over 2 times a. So I'm going to simplify that. 8, 24, positive 24. Negative times a negative is a positive. (24 plus 16 is root 40. And I know root 40 is the same thing as 2 root 10. And I'm going to split it because they're both being divided by 4, and I'm going to get to my final answer. The last thing that I do is I want to look to make sure that these two answers can fit in my domain. Okay, dividing by 2, that's okay. Dividing by 1, that's okay. Dividing by 4, that's okay. As long as I'm not dividing by 0, I can use both of these answers. This plugged in there, there's no places where I would divide by 0, so both of these answers should be correct. If you plug these values in, 1 plus root 10 divided by 2, and you square it and you divide it by 2 and you subtract another one of these things, you should get 3/4. You could plug it in and check if you would like. I'm not going to. Number 4, last example. The hardest thing about number 4 is figuring out what your LCM is. And remember, you want to think of these little denominators as a group. This x minus 3 is in a group with, this x minus 3 is a group in and of itself. Don't think that you can figure out what the LCM is of the 3 and the 4 by itself. These are in a relationship with each other because of those plus signs and minus signs. This is a couple, that's a couple. When you're looking for your little denominators LCM, you should be looking for one of these and one of those. Your LCM, I'm going to put for number 4, or LCM, is an x minus 3 multiplied by an x plus 4. What I can do is take that LCD or LCM and put it next to this term. I can put it next to this term. Put it next to this term. Technically, I'm multiplying the entire equation by x minus 3, x plus 4. And what happens is the x minus 3 can go into x minus 3 one time, and you're left with x times x plus 4. I know what that is. That's x squared plus 4x, and now there's nothing in the denominator. Plus the x plus 4 goes into x plus 4 one time, and you're left with this 2 times the x minus 3, which is 2x minus 6, equals And then what we're doing is 1 times anything is itself. I'm going to FOIL this out. And I'm going to get x squared plus 4x minus 3x is plus x minus 12. What's nice about this is that I don't have to worry about the fractions anymore at this point. Even though those denominators have gone away, it still might limit my domain just a little bit. I usually like to combine my like terms. And then what I like to do is say I'm going to subtract the x squared over here from both sides. I might subtract an x. 6x minus 1x is 5x. I might add the 6 as well. Negative 12 plus 6 is negative 6. And lastly, I'll divide by 5. And I want to make sure that my final answer fits for the domain of this function. It's not going to cause me to divide by 0, so that will be my final answer. I'm going to stop your notes right there.